In this video, we will discuss the Laplace transform of sinusoidal signals. Sinusoidal signals are sine function and cos function. See, to find the Laplace transform of sinusoidal signals, we have to apply here linearity property. Linearity property. So, first of all, I am writing sine function in terms of exponential signal. Sine of theta is, I want to write this complete sine function in terms of exponential signal. So sine of theta becomes e to the power of j theta plus minus, sine function expresses minus e to the power of minus j theta by 2j. Sine function in terms of exponential. And similarly, another signal is there, that is cos theta. Cos of theta. Cos of theta in terms of exponential is e to the power of j theta plus e to the power of minus j theta by 2. For cos function, plus symbol is used. For sine function, minus symbol. And sine function we have to write by 2j. And here only 2 is there. So, sine function, cos function in terms of exponential signals. Now I want to find out Laplace transform of sine theta. Laplace transform of sine theta. So now I am taking the simple representation like this. Laplace transform of sine theta, the theta multiplies with some constant, let us assume here bt. Sine bt into u of t. Into u of t means this complete sine function defined only positive time axis side. So defined from, time is from 0 to infinity. Negative time axis side it is not defined. Right? So Laplace transform of sine bt into u of t. To find this Laplace transform, first of all I want to apply this sine bt function in terms of exponential. See, I am writing like this now. Sine of bt is, so here sine of theta is e to the power of j theta. Then here it becomes e to the power of j into bt minus e to the power of minus j into bt by 2j. Sine bt I have wrote in terms of exponential signals. Now substitute this complete representation here. So Laplace transform of e to the power of j into bt minus e to the power of minus j into bt by 2j. So now I want to apply linearity property. Linearity property explains the total response is equal to sum of individual response. So 1 by 2j constant I am taking outside, 1 by 2j right outside. Right, this part is outside, right? And the remaining individual I am applying now. So u of t also there. Right, this complete function multiplies with u of t. This is compulsory. Right. So Laplace transform of e to the power of j into bt into u of t. Individual I am writing now minus Laplace transform of e to the power of minus j bt into u of t. U of t. Right. And just now we have discussed Laplace transform of exponential signal. Laplace transform of exponential function. That equation is like this. Laplace transform of e to the power of minus at into u of t is 1 by s plus a. Right. And similarly, Laplace transform of e to the power of plus at into u of t is 1 by s minus a. So here in this exponential signal t multiplies with a here, so that's why directly I have wrote 1 by s plus a, and here t multiplies with plus a and here 1 by s minus a. Now in this case, this t multiplies with which term? jb, and here minus jb. Then I want to apply this basic formulas in this equation. So finally this function becomes like this: 1 by 2j, this is constant, write it outside. Laplace transform of e to the power of jbt into u of t, that becomes 1 by s minus jb minus this function becomes now 1 by s plus jb. 1 by s plus jb. Then take LCM. Write s plus jb this side and s minus jb this side. Then it becomes like this: 1 by 2j. 1 by 2j. I am writing this s plus j this side, s plus jb, and write this complete term this side. Minus s minus into minus plus JB by this into this. S minus JB into S plus JB. Right? S minus JB into S plus JB, this looks like one standard mathematical equation, that is A plus B into A minus B. So A plus B into A minus B. Now it becomes A square minus B square. And here S get cancels. So finally which gives the 1 by 2j. SS get cancels. Now it becomes 2JB by A square minus B square. B is there, JB. A square minus B square. So S square minus JB square. J square is minus 1. J square is minus 1. Substitute that one here. And 2j get cancels. Finally which gives the B by A square plus B square. This is another standard mathematical equation. You have to remember this equation. Laplace transform of sin bt function. Laplace transform of sin bt into u of t is b by a square plus b square. One of the standard equation. Sinusoidal signal Laplace transform. Right? Now in this again I want to write Laplace transform of cos bt also. So again I am taking one more. Laplace transform of cos bt into u of t. So to find the Laplace transform of cos bt, again we have to apply this cos theta formula. So that formula I am applying here. Laplace transform of e to the power of jbt plus e to the power of minus jbt by 2 into u of t. Right? Then apply individually. Laplace transform applied individually here. 1 by 2 is taking outside. If you apply individually here, Laplace transform of e to the power of jbt is 1 by s minus jb, similar to this, right? And here minus symbol is there, but here plus symbol. So plus 1 by s minus jb. Then simplify this. Write s minus jb this side and s plus jb. S plus here, s minus and here s plus. Write s plus jb here and s minus jb here. Plus jb minus jb get cancels, and s plus s becomes 2s. 2 also get cancels. Finally, which gives the one answer, s by s square plus b square. Right? Now, the Laplace transform of cos of bt into u of t is s by s square plus b square. This is another standard equation. See, these two are similar equations here. Laplace transform of sin bt into u of t, denominator is s square plus b square. And cos bt also a square plus b square is there. Only the numerator part changes. For sin bt, the numerator is here b, because the coefficient here, constant value is how much? B is there, right? B by a square plus b square. And Laplace transform of cos bt is, right, s by a square plus b square. These are also some standard equations and Laplace transform of the sinusoidal signals. So these two are also important, because now onwards we have to write the Laplace transform of different functions here. To write those functions directly, we have to take, sometimes we have to take these formulas directly. So please remember these equations also. So please take this now.